A simple clay jar could rewrite the entire history of electricity. This is the story of the Baghdad battery, an artifact that suggests ancient people might have harnessed power 2,000 years before we thought it was possible. By the end, you will see a familiar timeline of human invention completely upended. We will examine how a chance discovery in the Iraqi desert ignited a firestorm among scholars and explore whether this object was a sacred container or a genuine ancient power source. What does it truly mean to be an inventor in a world where knowledge can vanish for centuries? The year was 1936, and the air over the Iraqi desert was thick with dust and the quiet rhythm of routine work. Archaeologist Wilhelm König sifted through artifacts unearthed from a 2,000-year-old Parthian site, a task he had performed countless times before. His hands likely passed over pottery shards and everyday tools, the common debris of ancient life. Then, one object made him pause. It was an unassuming clay jar, roughly the size of a man's fist, sealed shut with a dark, hardened plug of asphalt. Peering closer, he noted the meticulous construction. An iron rod was carefully suspended down the center of a rolled copper cylinder, all contained within the jar's simple walls. The interior surface was marked by a distinct, acidic corrosion. To anyone else, it might have been dismissed as a curious container for sacred scrolls or precious spices. But König saw a pattern that defied simple classification. He saw the components of a basic electrical cell, two dissimilar metals, and the clear evidence of an electrolyte. In that quiet moment of recognition, a simple jar transformed from a forgotten household item into one of archaeology's most tantalizing enigmas. This was not a discovery made in a king's tomb or a temple's inner sanctum. It was found in the soil of a common village, a humble piece of a puzzle that threatened to rearrange our entire understanding of technological history. Why would such a sophisticated object be created in an era we have always described as pre-scientific? What purpose could it have served that was so ordinary it was buried without ceremony, waiting 2 millennia for a curious mind to piece its secret back together? The Baghdad battery, as it would come to be known, began its modern life not with a fanfare, but with a single, profound question hanging in the desert air. König's startling observation demanded a closer look. To understand why this artifact is so disruptive, we need to deconstruct it piece by ordinary piece. At its heart, the Baghdad battery is a study in elegant simplicity. The outer vessel is nothing more than a hand-thrown clay pot, the kind used for storing grain or oil in households across the ancient Near East. Its very ordinariness is the first clue that this was not some ceremonial object for royal display. Sealing the jar's mouth is a plug of bitumen, a natural asphalt that was as common then as plastic is today. This material served a dual purpose. It kept the contents secure, and critically, it acted as a perfect insulator. Inside, the design becomes more deliberate. A sheet of copper was carefully rolled into a cylinder, roughly the length of your palm. Suspended perfectly down the center of this copper tube is a solid iron rod. The craftsmanship here is key because the iron does not touch the copper at all. The asphalt plug holds it firmly in place, maintaining a precise separation between the two metals. Now, this arrangement of dissimilar metals inside a sealed container is intriguing, but it's the final, missing ingredient that brings the theory to life. If you were to fill that jar with an acidic liquid, something as simple as vinegar, fermented grape juice, or even lemon juice, a quiet miracle would occur. The iron begins to corrode, a chemical process that releases tiny particles called electrons. These electrons naturally want to travel to the copper, and if you provided a path for them, like a thin metal wire, they would flow from the iron rod through that wire to the copper cylinder. That flow is, by definition, an electric current. While the voltage generated would be very small, perhaps 1 or 2 volts, it is undeniably present. This isn't speculative futurism, it's basic electrochemistry, and every component of the artifact aligns perfectly with that function. The clay pot contains the electrolyte. The bitumen insulates and seals. The copper and iron are the active electrodes. Together, they form a complete, albeit primitive, galvanic cell. The unavoidable implication is that someone, 2,000 years ago, understood this chain of cause and effect well enough to build it. They weren't just mixing metals by accident. They engineered a system where separation was mandatory and corrosion was the goal. This humble jar, then, isn't just an oddity. It is a blueprint, a silent argument written in clay, copper, and iron, waiting for us to read its instructions. But a blueprint without a purpose is just a theory. So what could this faint whisper of electricity, just a volt or so, actually do? To answer that, we need to step away from our modern world of bright lights and whirring motors. The current produced by a replica Baghdad battery is incredibly subtle. You could connect a dozen of these jars together in a series, and you still wouldn't get enough power to light a modern LED, let alone an incandescent bulb. So if it wasn't for illumination in the way we understand it, what was it for? The most compelling and widely discussed theory takes us into the spaces where science, craft, and spirituality blurred into one. Imagine a skilled artisan in a workshop, not with electric tools, but with delicate objects plated in thin layers of gold or silver. The process, known today as electroplating, doesn't require a strong current, but a steady, controlled one. An object made of a base metal like copper could be submerged in a solution containing gold particles. When connected to the negative terminal of a battery, the object attracts the positively charged gold ions, which then bond to its surface in a fine, even coating. This isn't wild speculation, there is a known precedent. Archaeologists have uncovered numerous small artifacts from Mesopotamia and ancient Egypt that are covered in remarkably thin, uniform layers of precious metal. Layers so fine that traditional methods like mercury gilding or hammering foil would be difficult to achieve with such consistency. Could the Baghdad battery have been the quiet, hidden tool behind this golden sheen? It's a tantalizing possibility that transforms the artifact from a mystery into a practical workshop device, a tool for adding sacred or royal significance to an object through a seemingly magical process. Yet, another theory suggests its use was not for adorning objects, but for affecting the human body. Ancient medical texts from the Greco-Roman world, which drew on knowledge from regions like Mesopotamia, describe using the mild shock from electric fish like the torpedo ray to numb pain, perhaps for headaches or joint ailments. If the sensation of a small electric current was recognized for its therapeutic or startling effect, could a priest or healer have used a device like this to create a controlled, repeatable version of that experience? The low current would produce a tingling sensation, a tangible, mysterious force that could be presented as divine touch or medical treatment. This shifts the purpose from the workshop to the temple or healer's room, making the battery a tool of ritual or early therapy. Both ideas, the practical and the mystical, force us to reconsider the landscape of ancient innovation. It suggests a form of technology not aimed at industrialization, but at augmentation, at enhancing the sacred, the valuable, or the experiential. The power wasn't in its strength, but in its precise application and the profound mystery of its source. So we are left with two powerful, competing narratives. One sees a clever artisan's tool, a breakthrough in metallurgy. The other sees an instrument of ritual, designed to bridge the gap between the seen and unseen worlds. Which vision feels more true, and is it possible that both could be correct, that a single simple device could serve multiple masters in a world that did not separate science from spirit? The idea of ancient electroplating turns a curious artifact into a practical workshop tool. For centuries, historians assumed that the brilliant gold and silver finishes on objects from this era were achieved through fire gilding, a perilous technique. This method involved mixing gold with liquid mercury, applying the paste to an object, and then heating it over a fire. The mercury would vaporize, leaving behind a gold coating, but the toxic fumes posed a severe risk to the artisan's health. It was effective, but it was also a dangerous, almost alchemical process of transformation. Now, consider the alternative presented by the Baghdad battery. A series of 10 such jars linked together with simple metal wires could produce a gentle, steady current of around 4 or 5 volts. This is not enough to be dangerous, but it is precisely the kind of low, controlled power ideal for a delicate procedure. In the 1970s, a researcher named Arne Egebrecht put this theory to the test. Using replica batteries filled with grape juice as the electrolyte, he created a small circuit and submerged a silver statuette in a gold cyanide solution. The result was a smooth, even micron-thin layer of gold deposited onto the object, a perfect plating achieved without fire, without toxic mercury, and with a quiet efficiency that feels almost modern. This experiment did more than prove a technical possibility. It painted a new picture of the ancient workshop. Imagine a craftsperson, surrounded by the familiar tools of their trade, who also possessed a sealed clay jar whose hidden function could summon an invisible force to bond precious metals. This would not be seen as electricity in our terms, but perhaps as a kind of controlled magic, a secret knowledge that gave their work an otherworldly quality. The artifacts themselves hint at this possibility. Many surviving pieces from the region, particularly small ceremonial items, show gold plating of remarkable uniformity, a consistency that is difficult to achieve with manual methods alone. The battery offers a clean, repeatable explanation. It transforms the artifact from a one-off mystery into a potential keystone of an entire craft tradition, a quiet technology that elevated metalwork from a skill to something approaching sacred art. This theory grounds the battery in the tangible world of commerce, royalty, and ritual adornment, making its existence not just plausible but profoundly logical. Yet the quiet hum of a workshop tool tells only half the story. If the battery's current could bond gold to silver, what might it have done when directed toward a living person? Ancient medical texts reveal a world where the lines between therapy and ritual were beautifully blurred. Greek and Roman physicians, drawing on knowledge that likely traveled the trade routes from the East, wrote of using the live torpedo fish. Patients suffering from headaches or joint pain would be instructed to stand upon the wet sand where these strange creatures lurked, receiving a series of mild, numbing shocks from the water. This was not superstition, but an observed, repeatable treatment, an early form of electrotherapy that genuinely provided relief. Now, picture a priest or healer who understood this principle. Instead of relying on the unpredictable catch of a fish, they could reach for a sealed clay jar. By attaching 2 copper wires to the terminals and placing them against a patient's temple or aching limb, they could administer a controlled, tingling current. The effect would be the same, a soothing numbness, but its source would be a profound mystery contained within a simple pot. This transforms the battery from a craft tool into an instrument of care, a tangible application of a natural phenomenon harnessed for comfort. The implications grow even more profound when we step from the healer's chamber into the dim, incense-filled space of a temple. In a world where the divine was felt as much as it was understood, the ability to manifest a hidden force would hold immense power. Imagine a small statue of a god, perhaps made of iron and copper, secretly connected by a wire to a battery hidden within an altar. When a devoted follower reached out to touch the statue's hand or foot, they would feel a distinct, unexpected vibration, a gentle buzz of energy. Or in a darkened room, a priest might draw two wires close together, producing a tiny, visible spark from the terminals. To a witness, this would not be a scientific demonstration. It would be a miracle, a literal spark of the divine made manifest through the idol. This use of the battery crosses into the realm of what scholars call a pious fraud, a deception intended to strengthen faith and centralize authority. It provided tangible, awe-inspiring proof of a priest's special connection to the gods, reinforcing social order and devotion. Here, the technology serves belief directly, creating experiences that cemented the supernatural into the sensory world. It bridges the gap completely, showing how a grasp of a natural principle could be wielded to shape reality, community, and the human spirit itself. So we are left with a single object possessing a dual legacy, one of the hand and one of the heart. It could plate a king's ring with celestial gold, and it could make a stone idol seem to breathe with sacred life. This duality may be the most important clue of all, revealing a time when innovation was not a separate path, but a thread woven seamlessly into the whole fabric of human experience, from the body's pain to the soul's longing. Yet for all the elegance of the battery theory, a powerful and necessary voice of dissent asks us to reconsider: could our modern fascination with technology be leading us astray? Many respected archaeologists look at the very same clay jar and see not a primitive power cell, but something far more ordinary, a secure container for sacred texts. In this skeptical view, every component has a mundane explanation. The iron rod was simply the spindle around which a precious papyrus or parchment scroll was wound. The copper cylinder was a protective sheath around that scroll, shielding it from the elements. The asphalt plug was nothing more than a perfect sealant, keeping out destructive moisture and insects in Iraq's climate, a practice well documented for preserving important documents. Over 2 millennia, the metals, dampened by residual organic acids from the decaying scroll itself, simply corroded together, creating the accidental chemistry we now interpret as evidence of intent. This perspective is not born of closed-mindedness, but of rigorous methodological caution. Its proponents point to a significant evidential gap. No wires, no connectors, no leads of any kind have ever been found with these jars. No ancient text from any nearby civilization describes the construction or use of such a device. If this was a known technology, even a secret one guarded by priests or guilds, wouldn't we find at least a hint in the vast record of art, literature, or administrative tablets? The absence is deafening. This counter-narrative warns of a trap known as archaeological pareidolia, the human tendency to see meaningful patterns like faces in clouds where none exist. It suggests we might be projecting our own electrified world view onto an object that was, in its time, simply a well-made box. This skepticism serves a vital purpose, grounding a thrilling mystery in the disciplined soil of evidence. It asks us to hold two competing truths in our minds at once: the thrilling possibility of rediscovered genius and the sobering possibility that we are the ones telling ourselves a story. The truth, as it often does in archaeology, may lie not in choosing one side, but in understanding the weight of both arguments. The true weight of this debate rests on understanding the ground from which the jar was pulled. To judge whether the Baghdad battery is a startling anomaly or a logical product of its time, we must step into the vibrant, interconnected world of the Parthian Empire. This was not a forgotten backwater, but a colossal superpower that ruled from the edges of the Roman Empire deep into Central Asia for nearly 5 centuries. Its greatest strength was its position as the central hub of the Silk Road, a sprawling network where caravans carried more than just silk and spices, they carried ideas. In the bustling markets of cities like Ctesiphon, a Greek philosopher could debate with a Persian astronomer, while a Chinese alchemist traded notes with an Indian mathematician. This was a melting pot of intellect on a scale the ancient world had rarely seen. Within this cauldron of exchange, the Parthians themselves were masterful engineers. They constructed vast, intricate networks of underground canals called kanats to irrigate their arid lands, a testament to their deep understanding of hydraulics and geology. Their architecture blended Greek and Persian styles into something new and imposing, and crucially, their metallurgy was exceptionally advanced. They were not just users of copper and iron, they were expert smiths who understood the properties of these materials intimately, crafting everything from formidable armor to delicate, gilded jewelry. So we have a society with access to all the necessary components, swimming in a sea of cross-cultural knowledge. They routinely used vinegar and fermented wines, understanding their acidic, preservative qualities. They mined and refined metals, observing how different ores behaved. In such an environment, the leap from observation to application is not so vast. A skilled metalworker, familiar with the strange tingle felt when handling certain corroding metals in a vinegar solution, might have pursued that sensation. An inquisitive priest, aware of the numbing shock of the electric fish described in Greek medical texts that traveled the Silk Road, might have sought to replicate it. The absence of a written theory of electricity becomes less of a barrier when you consider that many technologies develop through practical experimentation long before they are formally explained. The wheel was used for millennia before physics described torque and friction. The Parthian context provides the perfect fertile soil, a world rich with material knowledge and empirical curiosity where a discovery, whether intentional or accidental, could be recognized as useful. It creates a portrait of an era sophisticated enough to stumble upon a phenomenon and clever enough to find a purpose for it, even if that purpose was wrapped in the language of craft or ritual rather than the language of science. This doesn't prove the jar was a battery, but it dismantles the argument that such a thing was impossible. It transforms the artifact from an unthinkable anachronism into a question that fits perfectly within its historical moment. The real mystery then deepens. If they had this knowledge, however they understood it, how far did it spread, and why did its light seemingly go out? This brings us to a beautiful and deeply human possibility. Perhaps the Baghdad battery was never invented in a single moment of genius, but was instead born from a simple, everyday accident. Picture an artisan's workshop cluttered with tools and materials. An iron chisel is left to soak in a copper pot of vinegar meant to clean off corrosion. Or perhaps a vessel of fermented grape juice long past its prime is used to store a bundle of copper and iron scraps. Over days or weeks, a quiet reaction begins. Tiny bubbles form on the metal surfaces. If the artisan's hand brushed the liquid while touching both metals, they might have felt a faint, surprising tingle, a subtle vibration that had no obvious source. In a world attentive to the properties of materials, such an anomaly would not be ignored. A curious mind would ask why. They might experiment, trying different metals, different liquids, noticing which combinations produced the strongest sensation. Through patient hands-on trial and error, the optimal design could emerge. An iron rod suspended in a copper cylinder, sealed in a jar to hold the potent liquid. This path of discovery needs no textbooks or theories of electrons. It relies on observation, repetition, and a practical desire to harness a novel effect. We see this pattern throughout history. Alexander Fleming noticed a mold-killing bacteria in a contaminated Petri dish, leading to penicillin. Charles Goodyear accidentally dropped rubber mixed with sulfur onto a hot stove, discovering vulcanization. Wilhelm Röntgen found a mysterious glow from a cathode ray tube, revealing X-rays. In each case, a keen observer saw potential in an accident and pursued it. The ancient battery fits perfectly into this lineage of serendipity. It reframes the artifact not as a relic of a lost high science, but as a triumph of intuitive pragmatism. It speaks to the ingenuity of countless unnamed craftspeople who, through touch and observation, learned to manipulate their world in subtle, powerful ways. They may not have understood the physics, but they understood the result, a controllable force that could plate metal or produce a mysterious spark. This perspective makes the story more accessible and in some ways more profound. It suggests that groundbreaking innovation is often not a lightning bolt of abstract theory, but a slow, steady flame kindled from the sparks of everyday curiosity. The silent testimony of a single artifact is powerful, but science speaks the language of proof. To move beyond intriguing speculation, researchers turn to the laboratory bench, determined to see if the ancient design could truly hold a charge. This is the realm of experimental archaeology, where history is tested not with words, but with wires, voltmeters, and painstakingly crafted replicas. Starting in the 1930s and continuing for decades, curious minds have built countless versions of the Baghdad battery, adhering strictly to the materials of the era: hand-thrown clay pots, pure copper and iron, and natural electrolytes like vinegar or grape juice. The results are both consistent and fascinating. When filled, these replicas reliably produce a small but measurable voltage, typically between 0.5 and 1.5 volts. That is a scientific fact, not a theory. The artifact, by its very construction, functions as a basic electrochemical cell. Yet the experiments also reveal the profound limitations of this ancient technology. The current generated is vanishingly small, a mere whisper of electricity. The power fades quickly, often within an hour or two, as the chemical reaction depletes the electrolyte or the iron rod becomes too corroded. Perhaps most tellingly, while a single cell produces a tiny voltage, connecting several together in a series to create a more useful power source is not intuitive. It requires a specific understanding of linking positive to negative terminals, a concept that is not visually obvious from the jar alone. Some modern experimenters have achieved remarkable feats with these replicas. They have electroplated small silver statues with a fine layer of gold, just as the theory suggests. Others have connected a series of 10 or more jars to power a small, modern LED for a few fleeting seconds, creating a symbolic bridge across 2,000 years. But these successes are often accompanied by practical frustrations: internal short circuits if the metals touch, rapid depletion of the acidic solution, and the sheer effort required to maintain a stable current. So what do these experiments ultimately tell us? They confirm beyond any doubt that the object can serve as a battery. The design is electrically sound. But here lies the crucial distinction that every scientist understands. Proving something is possible is not the same as proving it happened. The laboratory can demonstrate function, but it cannot recover intent. It shows us the jar's potential, but not the hands that might have used it. This leaves us in a fascinating space of informed ambiguity. We hold a key that fits a lock, but we cannot be certain the lock was ever turned. The replications elevate the Baghdad battery from a curious oddity to a legitimate historical hypothesis, a question written not in ink, but in the quiet language of chemistry and copper, waiting for a context we may never fully find. The silent voltmeter reading from a replica is compelling, but it cannot answer the most practical question hanging in the air. Where are the wires for this clay jar to function as a true battery? It would need a conductor to complete the circuit, a bridge to carry that faint current from its terminals to something useful. Yet in all the excavations around Baghdad and similar sites, not a single wire, connector, or lead has been found in clear association with these jars. This evidential gap is not a minor detail. It is a chasm that skeptics rightly point to as the theory's greatest vulnerability. If this was a known and utilized technology, even within a specialized guild, we should expect to find the ancillary tools of the trade, workshops with multiple units, spools of metal strip, or even simple instructions etched onto a clay tablet. Their complete absence is deafening. Proponents of the battery theory offer plausible explanations for this silence. They suggest that any connecting wires could have been made from perishable materials that simply did not survive 2 millennia in the soil. Thin, flexible strips of copper or iron would corrode into indistinguishable dust. Even more likely, a craftsman might have used something as simple as a damp linen thread, soaked in the same acidic electrolyte, to carry the current over a short distance. After use, such a thread would dissolve or rot away, leaving no trace. Another possibility is that the process was entirely self-contained. For electroplating, a small object like a ring or a pendant could have been suspended directly into the jar itself, making direct contact with the terminals without any external wiring at all. In this scenario, the jar is both the power source and the plating tank, a neat, all-in-one apparatus that leaves little behind except the beautifully finished artifact. These explanations are reasonable, but they remain untested hypotheses. They ask us to believe in the invisible, to accept that the entire supporting infrastructure of this technology vanished without a whisper. This forces a difficult choice. Are we looking at a singular, anomalous object, a one-off experiment whose context is forever lost? Or is it a single surviving fragment of a wider, undocumented practice, a whisper of a craft so specialized that its tools were repurposed, melted down, or simply decayed into nothing? The missing wires do not disprove the battery, but they underscore a profound truth about ancient history. Our understanding is built almost entirely on what endures. The grand temples of stone tell their stories loudly, while the fragile technologies of thread, wood, and subtle knowledge often fade into silence, leaving behind only tantalizing, unanswered questions. The written record offers no easy answers, only a profound and telling silence. If the Parthians possessed a working battery, why is there not a single clear description of it in any surviving text? We have meticulous administrative tablets recording shipments of grain and wine, epic poetry, and complex astronomical charts, but nothing that explicitly details the construction or purpose of an electrical cell. This absence is the skeptic's strongest evidence, a void where we might expect to find at least a whisper of such a remarkable technology. Yet this silence may not be an absence of knowledge, but a reflection of how knowledge itself was protected and transmitted in the ancient world. Technological mastery was rarely a public science. It was a trade secret, a source of power and livelihood guarded as fiercely as any treasure. The formulas for legendary Damascus steel or the vivid Tyrian purple dye were not published. They were passed from master to apprentice in the closed environment of the workshop, spoken aloud and demonstrated by hand. This was an oral tradition of know-how, a living practice that died with its last practitioner, leaving behind only the mysterious products of their skill. So the lack of a manual for the Baghdad battery might not mean it didn't exist. It could simply mean its secret was successfully kept. Beyond this general silence, however, scholars have searched for oblique references, hints hiding in plain sight. Alchemical texts from the broader region, obsessed with the transformation and perfection of metals, sometimes speak of causing metals to shine or become untarnishing through mysterious processes. While these are often symbolic and spiritual, they could also be a veiled description of an observed physical phenomenon like electroplating. The famous relief in the Temple of Hathor at Dendera in Egypt, often sensationalized, depicts a large, bulb-like object containing a snake held aloft by a priest. While mainstream Egyptology interprets this as a symbolic representation of a lotus flower and a snake emerging from it, related to creation myths, its striking visual similarity to a modern light bulb has made it a frequent companion in discussions of ancient electricity. It is crucial to note this is a different culture, centuries removed and with no direct link to the Parthian artifact. Yet its persistence in the conversation highlights a human desire to find patterns, to see our own technological reflection in the sacred iconography of the past. These fragments, the guarded oral traditions, the ambiguous alchemical phrases, the visually suggestive carvings, are not proof, but together they sketch the contours of a possibility. They remind us that history is not just what was written down, but also what was deliberately kept out of the books, preserved instead in the silent language of crafted objects and the lost whispers of the guild hall. This single clay jar is not an isolated mystery. It belongs to a peculiar family of objects that archaeologists and historians call out-of-place artifacts, or OOP arts for short. These are items whose sophistication seems to defy the accepted timeline of human innovation, whispering of knowledge that appears too early, too precise, or simply forgotten. Placing the Baghdad battery among its peers reveals a fascinating pattern, not of a single era in our history books, but of a world where advanced understanding flickered in and out like distant campfires. Take, for instance, a lump of corroded bronze and wood pulled from a 2,000-year-old shipwreck near the Greek island of Antikythera. For decades, it was dismissed as a curious nautical clock. But when modern X-ray scans peered inside, they revealed an intricate system of at least 30 interlocking bronze gears, a mechanical computer capable of predicting planetary positions, lunar phases, and even the dates of ancient athletic games. This Antikythera mechanism, crafted in the 2nd century before the Common Era, displays a grasp of astronomy and precision engineering that would not be seen again in Europe for over 1,000 years. It was not magic, it was meticulous craftsmanship applied to a profound understanding of the cosmos. Then there is the Nimrod lens, a piece of ground rock crystal unearthed from an Assyrian palace dating to the 7th century before the Common Era. This oval of crystal is carefully shaped to magnify objects, and while some argue it was merely an ornamental inlay, its precise curvature suggests it could have served as a simple magnifying glass or even as a lens to concentrate sunlight. If so, it hints at an early, practical exploration of optics, a technology we often associate with a much later age. Across the north, the legendary Ulfbert swords wielded by Viking warriors tell a similar story of lost mastery. Forged between the 8th and 11th centuries, these blades were made of a steel so pure, so free of slag impurities, that they were stronger, sharper, and more flexible than any other European sword of the era. This was crucible steel, a material whose production method was a closely guarded secret, likely imported from the Islamic world along trade routes, and a technology that would not be independently replicated in the West for centuries. When we line up these artifacts, the geared computer, the ground lens, the super steel sword, and the potential battery, a compelling narrative emerges. They are not evidence of alien intervention or a single, lost super civilization. Instead, they are brilliant, isolated flashes of technical genius. They represent pockets of advanced skill that developed in specific places for specific purposes, often within guilds or workshops that guarded their secrets fiercely. This knowledge was not stored in public libraries, but in the hands and minds of artisans. It was fragile, vulnerable to the collapse of empires, the disruption of trade routes, or simply the passing of a master without a worthy apprentice. What these objects collectively suggest is that technological progress is rarely a smooth, upward line on a graph. It is a story of fits and starts, of brilliant local discoveries that shine brightly and then are extinguished, sometimes for millennia, waiting to be rediscovered by a different culture in a different time. In this grand, uneven tapestry of human ingenuity, the Baghdad battery finds its home. It may not be an impossible anomaly, but a quiet testament to a truth we often forget. Innovation can be born, can serve its purpose, and can then slip back into the shadows of history, leaving behind only a silent, puzzling artifact for a future age to wonder at. The rise of the Sasanian Empire did not erase the past, it built upon it. When the Sasanians swept to power in the year 224, they inherited the lands, the people, and quite possibly the intellectual capital of their Parthian predecessors. This new dynasty is remembered as a pinnacle of Persian civilization, a golden age of monumental architecture, intricate courtly arts, and breathtaking engineering. Their craftsmen were legendary for their work in metal and glass, producing objects of such dazzling complexity that they were coveted from Rome to China. If the Parthian workshop held a curious secret, a way to make metals gleam with a mysterious force, the question becomes inevitable: did that secret survive the change of crowns? The historical record offers no direct testimony of batteries, but it speaks volumes about the results. Sasanian metalwork is famed for its exquisite silver and gold plating, often applied with a fineness and uniformity that still impresses modern conservators. They perfected techniques like mercury gilding, yet the possibility remains that a quieter, cleaner method, perhaps one requiring a steady current, persisted in the most exclusive royal ateliers. Knowledge in the ancient world was not a public library, but a guarded treasure, passed in whispers from master to apprentice. A technique as subtle and potentially mystical as electroplating would have been the ultimate trade secret, a source of power and prestige for the imperial court. Its very value would have demanded its concealment. So we are left to wonder, did Sasanian artisans look upon a simple clay jar not as a relic, but as a vital tool, its function so mundane to them that it was never deemed worthy of special note in the grand chronicles of kings? This line of thought transforms the mystery from a solitary artifact into a potential thread in a much larger, hidden tapestry. It suggests a continuum of practical knowledge, a fragile chain of observation and skill that could stretch for centuries, utterly vital to the craftsmen who held it, yet invisible to the historians who would come later. The silence of the archaeological record from this later period is not a dismissal, but a deepening of the puzzle. Perhaps the design evolved, the clay jar replaced by a more efficient vessel that has not been identified. Or perhaps the knowledge was so tightly held that when the final cataclysm came, it broke the chain forever. That cataclysm arrived in the 7th century. The explosive rise of the Islamic Caliphate and the subsequent conquest of the Sasanian Empire in the year 651 was a world-altering event. It was not merely a change of rulers, it was a profound societal transformation. Libraries were burned, administrative systems collapsed, and the intricate network of Zoroastrian priestly and artisan guilds that sustained Sasanian high culture was dismantled. In this maelstrom of conquest and rebirth, how many delicate threads of technical knowledge simply snapped? A secret known only to a few masters in a royal workshop could vanish in a single generation, lost to war, dispersal, or a simple shift in religious and artistic priorities. The new Islamic civilization that rose from these ashes was a beacon of science and learning in its own right, but its focus shifted, building magnificent new traditions in mathematics, astronomy, and medicine. The potential for a forgotten, practical electrochemistry might have seemed like a trivial curiosity, a magician's trick without a theoretical framework to give it lasting importance. So the thread, if it ever existed, may have frayed and finally dissolved in the turbulent winds of the 7th century, leaving the Baghdad battery as its lone, cryptic knot, a single point of light from a tradition that otherwise faded into absolute darkness. This perspective asks us to consider history not as a steady accumulation, but as a story of fragile legacies where brilliant flames can be kindled, can burn brightly for a time, and can then be snuffed out by the tides of time, leaving behind only the faintest scent of smoke and a haunting question about what warmth they once provided. This quiet artifact from the Iraqi soil now lives a second, far louder life in our modern imagination. The Baghdad battery has long since escaped the confines of museum cases and academic papers, becoming a star player in a thrilling genre of storytelling. You will find it featured in best-selling books and dramatic television documentaries that speak of ancient astronauts, lost super-civilizations like Atlantis, and histories deliberately suppressed by the establishment. These narratives are undeniably compelling, weaving tales where the battery was part of a vast ancient power grid, perhaps used to illuminate the dark chambers of Egyptian pyramids with brilliant electric light. The image is powerful, a direct challenge to everything we thought we knew. Yet here lies a crucial crossroads for any curious mind, the point where historical inquiry parts ways with sensationalized speculation. It is vital to recognize the difference. The popular stories often take a single point of evidence, the jar's electrical potential, and construct an entire invisible empire around it, while dismissing the lack of wires, texts, or corroborating artifacts as proof of a cover-up. This approach trades the messy, ambiguous work of archaeology for a cleaner, more exciting story, one that often says more about our own time than about the past. Our era is defined by rapid technological change and a certain distrust of official narratives, so the idea that ancients possessed a secret wisdom lost to time resonates deeply. It reflects our own anxieties and wonders, our desire for hidden truths and forgotten golden ages. Engaging with this modern mythos is not a waste of time. It helps us understand the powerful grip this object has on the public mind. The battery becomes a mirror, showing us our own fascination with the idea that breakthrough knowledge can be fragile, can be lost, and might be waiting just beneath the surface of accepted history. Its true value, however, lies not in proving the existence of alien visitors or Atlantis, but in the far more profound and legitimate questions it raises about the actual, achievable boundaries of ancient innovation. It forces professional historians to refine their arguments and reminds all of us that the human capacity for discovery is not a linear path, but a landscape dotted with flashes of brilliance that may flicker out, waiting centuries for another spark to reignite them. Science could settle this debate with a single, definitive test. If we could examine the original clay jar with the tools of modern materials science, its chemical story might finally be told. The specific type of corrosion on the iron rod and copper cylinder is a potential fingerprint. Prolonged contact with an acidic liquid like vinegar or wine leaves a distinct signature on metal, different from the patterns caused by simple burial in damp soil. Even more telling would be residue trapped inside the jar or within the porous clay itself. A careful analysis could, in theory, identify the exact electrolyte used 2,000 years ago. Modern techniques like X-ray fluorescence spectroscopy or mass spectrometry are sensitive enough to detect trace elements, perhaps even the microscopic remains of a chemical reaction that produced a current. This is where the pursuit of a historical truth collides with a painful modern reality. The original Baghdad battery artifacts, along with countless other irreplaceable treasures, were housed in the National Museum of Iraq in Baghdad. During the conflicts that have affected the region in recent decades, the museum suffered catastrophic losses. Looting, damage, and the chaos of war scattered or destroyed a vast portion of the collection. The current whereabouts and condition of the specific jars studied by Wilhelm König are uncertain. Some may be lost forever, others may be damaged, their surfaces contaminated, their internal chemistry altered beyond reliable analysis. This is a profound tragedy that extends far beyond a single mystery. The loss of cultural heritage in this way erases chapters of the human story, burning the very libraries of our shared past. It makes the task of the historian and the scientist immeasurably more difficult, forcing us to rely on old photographs, sketches, and the descriptions from a century ago rather than the object itself. This context makes the few surviving artifacts all the more precious. It also places a great responsibility on future discoveries. Should another sealed jar be unearthed in a stable, archaeological context, it could be analyzed immediately with non-invasive, cutting-edge technology. Scientists could search for that chemical fingerprint, the unique marker of an intentional electrochemical cell. They could look for residue on the asphalt plug, analyze the corrosion products with nanometer precision, and perhaps even attempt to identify organic compounds that have long since evaporated. Until such a discovery is made and rigorously studied, the battery theory remains in a state of elegant suspension. It is a hypothesis supported by compelling engineering logic and replicable experiment, yet awaiting the final material witness that only the original artifact can provide. The mystery persists not for lack of scientific method, but because the primary evidence itself has become a casualty of time and turmoil, a silent reminder that our window into the past is fragile, and every piece we lose dims the light on our own origins. That silent clay jar holds a power far greater than a single volt. Its true voltage is measured not in electricity, but in its potential to rewrite our story of human ingenuity. If we could prove beyond any lingering doubt that this was an intentional device, the timeline of science itself would fracture and reassemble. The birth of electrochemistry would be ripped from the notebooks of Alessandro Volta in the year 1800 and thrust back into a Parthian workshop nearly 2 millennia earlier. This is not about finding a modern theory in an ancient mind. No one is suggesting they understood electrons or electromagnetic fields. It is about something equally profound, applied knowledge. It reveals a society that could observe a mysterious natural phenomenon, the tingling connection between two metals and an acid, and then systematically engineer a tool to harness it. They moved from noticing an effect to building a cause, a leap that defines practical science. This single adjustment to our historical lens changes everything we see afterward. It forces us to reconsider those long centuries often labeled as a technological pause in the West. Perhaps they were not an era of universal stagnation, but a period where certain brilliant threads of knowledge, spun in places like Mesopotamia or Persia, were temporarily lost or lay dormant, waiting to be respun elsewhere. The narrative of scientific progress has often been drawn as a straight, ascending line from ancient Greece to Renaissance Europe. The Baghdad battery, if validated, becomes a stark reminder that this line is an illusion. The true history of discovery is a vast, tangled web, a global network of insights that flare and fade across continents and cultures. This artifact would represent a forgotten node in that web, a point of light in one region that went dark, while other points eventually brightened into the science we know today. It challenges the comfortable, Eurocentric story that credits all foundational breakthroughs to a single geographical and intellectual lineage. Instead, it suggests a more humbling and exciting truth: innovation is a human trait, not a cultural monopoly. Genius can spark anywhere, be used for a time, and then its embers can be scattered by the winds of history, only to be kindled again, independently, by minds 1,000 miles and 1,000 years away. The jar asks us to replace a simple timeline with a richer, more complex tapestry, one where progress is not a race with one winner, but a collective, often interrupted, journey of the entire human family. The barrier was never one of materials or basic skill. Every component of the potential battery was a staple of daily life in the ancient Near East. Clay pots were the plastic containers of their era, molded by countless hands for storage and transport. Bitumen, that sticky, black asphalt, oozed from natural seeps in the region and was used for everything from waterproofing boats to cementing bricks. Copper and iron were the essential metals of civilization, worked by smiths into tools, weapons, and ornaments. Even the electrolyte was sitting on every kitchen shelf or in every wine cellar, in the form of vinegar, sour wine, or the juice of a lemon. From a purely material standpoint, constructing the device required no exotic imports or secret alloys. It was a project within reach of a modest workshop, a collaboration between a potter, a coppersmith, and a blacksmith, each using their ordinary, well-understood crafts. The assembly itself lacks any need for microscopic precision. The iron rod simply had to be suspended so it did not touch the copper cylinder, a task easily managed by embedding it in the asphalt plug. There are no delicate gears like the Antikythera mechanism, no complex alloying like the Ulfbert swords. The physical creation of a Baghdad battery replica is, in fact, a straightforward afternoon's work for someone familiar with these ancient materials. This simplicity is what makes the artifact so provocative. The real question shifts from could they build it to would they have thought to build it. The leap from possessing the parts to assembling them for this specific, subtle purpose is a leap of the mind, not the hands. It begins with observation. An artisan might have noticed that an iron tool left in a copper pot of vinegar developed a strange, gritty corrosion, different from rusting in water. Perhaps they felt a faint, surprising tingle when handling both wet metals at once. In a world without the constant hum of background electricity, such a sensation would be notable, a tiny mystery embedded in the routine of the workshop. A curious, empirical mind, the same kind of mind that first observed fermentation or learned to control fire, might then begin to experiment. What if the metals were arranged differently? What if a stronger vinegar was used? Through trial and error, the most effective configuration could be discovered: the sealed jar, the separated metals, the acidic bath. The final, crucial step of connecting the metals with an external wire or damp thread to complete the circuit is the only non-obvious part. Yet even this could be stumbled upon. If two such jars were placed side by side and a person touched the iron of one and the copper of the other, completing a circuit through their own body, they would feel that tingle amplified. From there, the idea of using a metal strip or a brine-soaked string to bridge the gap is a short, logical hop. Therefore, the entire process, from observation to a working cell, resides firmly within the realm of possibility for an ancient craftsperson. The replication was not just feasible, it was almost inevitable for a culture that valued materials and their properties. The greatest hurdle was not technical capability, but the conceptual spark to see a curious side effect as a tool waiting to be built. It is the difference between seeing a spark from striking flint and conceptualizing a forge, a moment where utility is born from a simple, repeated wonder. A mere dozen similar jars rest in museum collections worldwide, a hauntingly small number to bear the weight of such a grand claim. They are not a uniform set either. Some lack the signature iron rod entirely, holding only a copper cylinder. Others show different arrangements of the metals, or jars of slightly varying sizes and shapes. This inconsistency is not a minor detail, it is the statistical heart of the mystery. If this was a standardized tool, a piece of widespread technology, we would expect to find hundreds, perhaps thousands of examples across the region, like the ubiquitous clay oil lamps or common storage vessels that fill archaeological warehouses. Their scarcity speaks loudly. To a skeptic, this variation and rarity point decisively away from a deliberate invention. They suggest we are looking at a family of ordinary storage jars, perhaps used to hold precious scrolls or volatile compounds, where the occasional presence of metal fittings is purely functional or coincidental. The iron rod was a spindle, the copper cylinder a protective case, and any acidic residue simply came from the organic contents they were meant to preserve. In this view, the dozen jars are not a technological sample. They are a statistical fluke, a handful of peculiar containers that we have mistakenly grouped together and imbued with modern meaning. Proponents of the battery theory face this scarcity head-on, and their explanations hinge on the fragile realities of ancient life and modern archaeology. First, consider the object itself. A clay jar, even one sealed with bitumen, is inherently breakable. After its useful life, the metals inside copper and iron were incredibly valuable. They would have been prime candidates for recycling, melted down to become a coin, a tool, or a piece of jewelry. The ceramic shell, once cracked open, would be discarded as worthless potsherds, indistinguishable from a million others. What we have found, then, might not be the discarded tools, but the extraordinarily rare examples that were sealed, forgotten, and buried before they could be stripped for parts. Furthermore, our archaeological map is profoundly incomplete. We have excavated only a tiny fraction of the ancient world, and often only the grand, stone-built monuments intended to last. The humble workshops where such a device would have been used are far less likely to be found and meticulously sifted. The jars we have were discovered by chance, not by targeted digs for ancient laboratories. So the argument is not that they were common, but that they were specialized, valuable, and ultimately fragile, a recipe for near-total disappearance from the material record. This is the core of the statistical dilemma that makes the Baghdad battery so endlessly debatable. In archaeology, a technology is typically confirmed by a preponderance of evidence, multiple examples found in clear contexts like workshops alongside associated tools and perhaps described in text. Think of Roman concrete, evidenced by countless structures, quarry sites, and even descriptions by architects like Vitruvius. The battery hypothesis asks us to accept a different kind of evidence, the rare survivor. It requires a leap of inference to believe that this handful of jars represents the last whispers of a practice that was once understood, utilized, and then utterly lost. This places the artifact in a frustrating category. It can never be statistically proven, only logically supported. It stands as a single data point on a vast, empty graph, a point we can either dismiss as noise or connect to an invisible line of lost knowledge. The choice we make says less about the ancients and more about how we interpret silence. Do we see absence as proof something never existed, or as an invitation to wonder what else might have vanished without a trace? This thin line between tool and talisman forces us to ask a deeper question. What did power mean to someone living 2,000 years ago? For us, power is quantifiable. It is volts in a battery, watts in a light bulb, a utility we purchase and control. In the ancient mind, power was a more fluid and sacred concept, a force that flowed through the natural world, the human body, and the realm of the gods. A device that could generate a mysterious tingle or make metal gleam with a golden sheen would not be filed under science. It would be perceived as a tangible fragment of that universal power, captured and directed by human ingenuity. In such a world, the artisan who operated it and the priest who interpreted its meaning held a profound and dangerous authority. They were not just technicians, they were intermediaries, individuals who could manifest the unseen. This explains why such knowledge would be guarded with absolute secrecy. A technology that could demonstrate divine presence or even simulate it was far too potent to be shared. It was a source of social and spiritual capital, reserved for the inner sanctums of temples or the exclusive service of a king. The very absence of widespread evidence, the frustrating lack of instruction manuals or mass-produced jars, becomes a clue in itself. It suggests not a forgotten common tool, but a carefully controlled mystery, a secret so valuable that its practice was deliberately kept small, oral, and hidden from record. When we view the potential battery through this lens, its physical function becomes secondary to its cultural meaning. The question shifts from a technical "how did it work" to a philosophical "what did it represent?" It becomes a symbol of an enduring human aspiration, the desire to reach into the invisible fabric of the world and pull forth a thread of influence. This was not a quest for convenience but for connection, for a means to touch the divine, to transform the mundane into the sacred, and to command respect through the demonstration of hidden forces. The artifact, therefore, stands at a crossroads. It can be seen as a prototype for all our modern gadgets, a seed of practical engineering. But perhaps more accurately, It is a mirror reflecting a holistic world where every action, from plating a ring to healing an ailment, was woven into a single, interconnected tapestry of matter and spirit. The true spark it generated may not have been electrical but symbolic, a fleeting glimpse of how our ancestors sought to bridge the gap between the earth they walked on and the mysteries that shimmered just beyond their understanding. Perhaps the jar was never meant to be opened at all. Another compelling interpretation invites us to step away from the workshop and into a space of profound symbolism. Beyond the straightforward idea of scroll storage, scholars have proposed that this sealed vessel served a purely ritual or ceremonial purpose. In this view, the jar was not a tool, but a sacred object, a complete and self-contained component in a larger apparatus of belief. Imagine it placed on an altar not to generate current but to enact a spiritual metaphor. The combination of metals inside could have held deep cosmic meaning. Iron, strong and reddish, was often linked to Mars, the god of war and masculine force. Copper, malleable and with a warm glow, was associated with Venus, embodying love, beauty and feminine energy. Sealed together within the earthy clay, surrounded by a potent liquid, these opposing principles could have been seen as enacting a divine union, a symbolic transformation of elements mirroring the alchemical quest for perfection. The acidic liquid itself might have been something like sacred wine or vinegar, chosen not for its electrical properties, but for its symbolic purity or its role in purification rites. If a reaction did occur within the sealed jar, if the metal slowly changed and a faint energy was somehow sensed, it would not have been seen as a chemical process to be harnessed. It would have been witnessed as a miracle, a quiet sign of divine presence or alchemical transmutation happening invisibly within the sacred container. The very mystery of its internal process would have been the point. This interpretation resolves a key tension in the battery debate. It allows the artifact to be profoundly significant without requiring its creators to have understood or intended electrochemistry in a modern sense. It situates the jar firmly within the rich, symbolic framework of its time, a framework where an object's power was measured by its connection to the cosmos, not by its measurable output. We, as modern observers, often struggle to fully comprehend a worldview where every material carried a spiritual weight, where the boundary between a practical substance and a sacred symbol was beautifully blurred. In such a world, engineering a marvel was less important than encapsulating a mystery. The jar's true purpose may have been to sit in solemn silence, a physical prayer whose meaning was held not in its function, but in its mere enigmatic existence. Wilhelm König's own story is as layered as the artifact he studied. A trained archaeologist and conservator, he approached the jar not as a treasure hunter, but as a methodical observer. His initial report, written for the museum, was measured and cautious, noting the unusual construction and the acidic corrosion without jumping to grand conclusions. It was the work of a professional documenting a curious find, yet in his later writings a shift occurred. The tone grew more confident, the interpretation more pointed. He began to explicitly frame the object as a galvanic cell, an ancient battery. This evolution in his thinking is precisely where the debate around the man himself ignites. Critics suggest that König, living in the 1930s and 40s, was a product of his electrified age. This was the era when household electricity became commonplace, when radios crackled to life in living rooms, and the marvels of applied science defined modern progress. Could this context have unconsciously shaped his vision? Did he see a battery in the clay because his world was suddenly full of them? It is a compelling argument for anachronism, the mistake of imposing modern concepts onto the past. From this perspective, König was not an objective analyst, but a speculator whose imagination was sparked by the technological zeitgeist. His training might have led him to recognize the components, but his culture told him what they must have been for. Proponents of the battery theory, however, see a different narrative. They argue that König's growing conviction was not projection, but the natural result of prolonged study. The more he examined the jar, the more the pattern solidified. The precise separation of metals, the insulating asphalt, the specific corrosion, all pointed toward a single, logical function. In this view, his later writings reflect not bias, but the courage to follow the evidence where it led, even toward a revolutionary idea. König's legacy, therefore, is profoundly mixed. To some, he is the insightful scholar who cracked a 2,000-year-old code, pulling a thread that unravels our historical timeline. To others, he is a cautionary figure, a reminder of how easily our own worldviews can color the artifacts we unearth. His story transcends archaeology, becoming a lesson in the philosophy of science itself. It highlights that discovery is never a purely objective act. It is a conversation between the evidence in the ground and the mind examining it, a mind that is always, inevitably, a product of its time. Regardless of where the ultimate truth lies, König achieved something remarkable. He took an obscure, unassuming pot from a museum shelf and placed it firmly at the center of a global conversation, a debate about human ingenuity that has now sparked, challenged, and fascinated us for nearly a century. His interpretation may be contested, but his question endures. The dream of turning lead into gold was not mere fantasy. It was a driving force of early science. This pursuit, known as alchemy, sought the ultimate secrets of matter, and its shadow falls directly across the Baghdad battery. At its core, alchemy was the quest for transformation, the belief that through hidden processes, a base substance could be elevated into something perfect and pure. If the jar was indeed used for electroplating, it achieved precisely that, taking a common object of copper or silver and bestowing upon it a skin of radiant gold. This was not a symbolic change, but a real, physical transmutation, accomplished not by incantation, but through the quiet application of a mysterious natural force. In this light, the humble clay vessel transforms into something far more potent, a practical philosopher's stone. It becomes a tool that harnessed what we now call electricity to enact the alchemist's deepest dream, turning the ordinary into the precious right before their eyes. This connection weaves the artifact into a much grander tapestry of human thought. It shows us that the lines we draw today between rigorous experiment and spiritual pursuit simply did not exist in the same way. For an ancient artisan or scholar, understanding a material's property and unlocking its hidden, divine potential were two sides of the same brilliant coin. The great alchemical traditions of the Islamic Golden Age, pioneered by minds like Jabir ibn Hayyan, were deeply empirical. They involved meticulous observation, careful documentation of reactions, and the development of early laboratory equipment. Their work was a fusion of spiritual symbolism and hands-on technique, seeking to reveal the unity of the cosmos through the transformation of metals. A device that could silently deposit gold onto another surface would have been a treasure beyond measure in such a tradition, less a battery and more a sacred apparatus. It represents a moment where a mystical goal found a physical method, where the yearning for perfection discovered a tangible, repeatable path. This perspective resolves the apparent contradiction of the artifact's silence in the historical record. Its secrets would not have been published in a book for all to read. They would have been guarded within closed circles of initiates, passed down as the ultimate craft mystery, a literal manifestation of hidden knowledge. The battery, therefore, stops being an outlier and becomes a logical piece of a forgotten puzzle. It bridges the gap between the workshop and the library, between the hands of the metalworker and the mind of the sage. It reminds us that our ancestors did not compartmentalize the world as we do. They sought a unified understanding where every spark, every gleam of metal, and every transformation held the potential to reveal the underlying order of the universe. The silent clay jar has taught archaeologists as much about their own methods as it has about the past. This enduring puzzle has become a cornerstone of experimental archaeology, a field dedicated to testing history with hands-on replication. Here, the Baghdad battery serves as the ultimate classroom, a perfect case study in how to interrogate a historical hypothesis with rigor and imagination. The process begins with an absolute rule: use only what was available. Researchers cannot reach for modern wires or a lab-grade power supply. They must source hand-thrown clay, smelt copper and iron using period techniques, and seal their jars with natural bitumen. The electrolyte must be something as simple as vinegar or fermented grape juice. This material fidelity is the first, crucial step in bridging the centuries, ensuring any result speaks to ancient capability, not modern convenience. But true replication demands more than just materials. It requires a shift in mindset. The experimenter's greatest challenge is to shed the perspective of a modern engineer and instead think like an ancient artisan. This means setting aside goals of efficiency or maximum output. An ancient craftsperson might have valued a slow, steady current for a delicate plating job over a brief, powerful surge. They would have worked within the knowledge frameworks of their time, perhaps viewing the process through a lens of alchemical transformation or sacred ritual rather than electrochemical theory. Successful experiments, therefore, must design use cases that feel plausible within that ancient world. Can the cell plate a small ring with a consistent layer of gold? Does the tingling current it produces have a noticeable effect that a healer or priest might find meaningful? These are the questions that move replication beyond mere technical demonstration and into the realm of historical interpretation. This rigorous process has sparked profound methodological debates that echo far beyond this single artifact. The central, haunting question remains: when does a successful replication actually support a historical hypothesis? Proving that something could have worked is not the same as proving that it did. A working replica demonstrates fascinating possibility, a door that was technically unlocked, but it cannot, on its own, prove that anyone ever walked through it. This distinction is the delicate line experimental archaeologists must walk. The battery's legacy, therefore, is not merely a contested chapter in the history of science. It has actively sharpened the tools of archaeological inquiry, forcing the discipline to refine its standards for evidence, to embrace interdisciplinary collaboration with chemists and materials scientists, and to humbly acknowledge the limits of what can ever be truly known. In this way, an unsolved mystery has become a powerful engine for methodological innovation, proving that the deepest questions often teach us the most about how to ask better ones. The path forward for this ancient mystery now hinges on a delicate blend of patience and technology. To move beyond elegant speculation, the quest requires two things: a fresh discovery and the tools to examine it without causing harm. Archaeologists dream of finding another sealed jar, but this time in an undisturbed context, perhaps nestled on the floor of a clearly defined workshop, surrounded by the very tools of its trade. Imagine uncovering a small cache with several such jars, a roll of thin copper strip that could serve as wiring, or even a ceramic vessel with terminals still connected by a trace of mineralized residue. Such a context would be transformative, shifting the artifact from an isolated puzzle piece to a component of a recognizable system. Until that day comes, science offers other avenues. Non-destructive testing is the key. Modern techniques like mass spectrometry could analyze the faintest chemical fingerprints left inside an intact jar, searching for the unique molecular signature of vinegar, wine, or another acidic electrolyte. Advanced imaging could map the corrosion on the iron rod with nanometer precision, distinguishing between patterns caused by a deliberate electrochemical reaction and those from simple burial. Each test performed without breaking the seal preserves the artifact for future, even more advanced methods. Meanwhile, scholars continue their quiet work in libraries and archives, re-examining ancient texts not for a direct description of a battery, but for oblique references, a passing mention of a jar that makes metal shine, or a vessel of tingling water in an alchemical manuscript or a trade ledger. The search is for echoes, not blueprints. This enduring enigma thrives because it lives in two worlds, the rigorous world of academic debate and the vibrant realm of public fascination. It is that widespread curiosity, fueled by documentaries and books, that provides a vital energy, encouraging experts from isolated fields to collaborate. A chemist might not routinely read archaeological journals, and an electrical engineer may not study Parthian history, but the Baghdad battery brings them to the same table. This interdisciplinary conversation is where the most exciting insights are born, as a materials scientist explains corrosion patterns to a historian, who then reinterprets a text in light of that data. The public's role is not as passive spectators, but as custodians of the question itself, ensuring it remains alive and worthy of investigation across generations. So what ultimately do we still need to know? The core questions remain deceptively simple. Was this object a single artisan's brilliant experiment, a fleeting spark of genius that died in that one workshop? Was it a standardized, if specialized, tool used by a guild of metalworkers or priests across the region? Or was it primarily a ritual object, a sealed symbol whose function was spiritual rather than practical? And if the knowledge did exist, however it was understood, did it travel? Did the concept of this captured force spread along the Silk Road to other cultures, where it might appear under a different guise, or was its light so carefully guarded that it was extinguished forever within a single tradition? The Baghdad battery, in its stubborn silence, refuses to give us these answers, and that is perhaps its greatest gift. It stands as a powerful, humbling monument to the limits of our knowledge. It reminds us that the past is not a solved puzzle, but a vast landscape where our understanding is built on the fragments that survived the relentless sieves of time, conflict, and decay. This single, humble jar holds a profound potential, not just to alter a timeline in a textbook, but to reshape our very perception of human ingenuity. It urges us to look at the ancient world not as a precursor to our own, but as a place of independent, sophisticated discovery, where brilliant ideas could rise, serve their purpose, and vanish into the soil, waiting centuries for us to stumble upon them and begin the beautiful, frustrating work of wonder all over again. The Baghdad battery remains an enigma wrapped in a clay jar. It is a puzzle that sits precisely where archaeology, chemistry, and the story of human ingenuity meet. We have traced its path from a chance find in the Iraqi desert to the controlled environment of the modern laboratory, weighing the elegant theory of an ancient power source against the cautious voice of academic skepticism. We have explored its potential as a tool for gilding sacred objects and its possible role as an instrument of ritual, a bridge between the tangible and the divine. Whether this artifact was a deliberate battery, a ceremonial vessel, or merely a well-sealed container, its ultimate power does not rest in a definitive answer. Its true significance lies in the profound questions it compels us to ask. It challenges the comforting idea that progress is a straight, unbroken line from primitive past to enlightened present. Instead, it suggests a history punctuated by brilliant flashes of local genius, technologies that flared like sparks in the darkness only to fade, their light swallowed by time, conflict, or simple forgetting. This humble object is a monument to the fragile, ephemeral nature of knowledge itself. It reminds us that our understanding of the past is built not on complete libraries, but on fragments that survived the relentless sieve of centuries. So as we leave this mystery still hovering in the air, consider this. History is not a closed book with all the answers neatly printed in the final chapter. It is an ongoing investigation, a conversation between what we find and what we dare to imagine. Countless secrets likely still rest beneath the soil, each one holding the potential to quietly rewrite the stories we tell about who we are and where we came from. What do you believe the Baghdad Battery truly was? Share your perspective in the comments below. And if you enjoyed this journey into the shadows of history, subscribe for more explorations into the world's enduring mysteries.